So for this question here, we see in the picture, immediately we can see there are these two objects, and we've got a collision going on. So, I mean, that's what should strike us right off the bat, is that there is a collision. Okay, and so collisions bring us to the concept of momentum. All right, so trolley mass 4 moving on a frictionless surface with a speed of 2 meters per second. So we've got a momentum equal to mv. So we've got 4 times 2 is 8. And if this is the positive direction and that's the negative direction, we have positive 8 momentum. Great. And it's a stationary is this other one. So this momentum is 0, which shows a possible outcome of this collision. Well, what governs this is the law of conservation of momentum, which says the initial momentum equals the final momentum, equals the momentum at all times, at any time. And we know the initial momentum consists of the momentum of the first object plus the momentum of the second object. The first object, we already calculated, has a momentum of 8, and the second object has 0. So we are looking for a situation that has a momentum of 8 afterward. So when we look at this one, we see this one's stationary, so that's 0. 4 times 2 is 8. Oh, so it looks like that's our answer, but we're going to keep going. So we have mv here. We've got 8 kilograms times 2 is 16. That is not possible. And in this case over here, we have mv, which is 0, and here we have mv, which is 4 times minus 2, which is minus 8. That is very different. The momentum beforehand is positive. So the momentum of the system afterward must also be positive. And in C, it's negative. That can't be. And in the last one, we have mv. We've got a mass of 8 and a velocity of 0, so 0. So we were, in fact, correct that the answer is choice A.